next rule is the constant multiple rule, which is a very official name for the coefficient rule. So you can think of this as, what should we do if we're trying to derive some kind of expression that has a coefficient? Okay, so looking at our expression right here, the coefficient is c, and then the rest of the term is the f of x. So it can be proven, using the definition of the derivative, that if you have a coefficient, that coefficient will move from the function right into the derivative. So in other words, if we have a coefficient here, that will be, when we take the derivative, that same coefficient will be in the derivative. So the coefficient moves untouched, and then the rest of the term gets derived as usual. So f of x, we will derive that to f prime of x. Okay, so that's just a general form of what's going on. Let's look at some examples, and I think this may clarify things up. So, for example, let's say that we have f of x is equal to 4x cubed. Okay, we're looking to find the derivative of 4x cubed. So if we break down the 4x cubed, 4 is the coefficient, x is the base, and then 3 is the exponent. So the 4 matches with the coefficient, the c right here, and then the x cubed matches with that, the rest of the term, the f of x right there. So by definition, when we're going for our derivative, okay, the coefficient moves right into the derivative. So this 4 will be a part of our derivative. And then the remaining part of the term, which is x cubed, well, that's going to be derived as usual. We already know the derivative of x cubed. We use our power rule. 3x squared will be the derivative. So the 4 moves down, and then the x cubed derives to 3x squared. And this means that we can, yes, in fact, combine the 4 and the 3, and we have a final derivative of 12x squared. Okay, so you don't have to show this middle step as you get more and more used to doing these terms. You can say, okay, well, the 4 and the 3, they multiply to 12, and then I knock one unit off of the exponent, so it goes from x cubed down to x squared. Okay, you can absolutely use this middle step to help you get to the final term, but ultimately you're going to go from 4x cubed to the derivative being 12x squared like that. Okay, let's do another example or two. If we have example 2 here, let's try this one. G of x is equal to 8x to the 1/2. Okay, well, 8's the coefficient, x to the 1/2 is the rest of the function. So by definition, our derivative, the 8 will move down, okay, and then x to the 1/2, we're going to derive that using our power rule again, just like we used the power rule to turn x cubed into x squared. We've done x to the 1/2 already. We know that we'll have 1/2, and then we'll have x to the negative 1/2 by using the power rule. The 1/2 comes out front, and then we subtract 1 from the exponent to get negative 1/2. And then can we combine the 8 and the 1/2? Absolutely. So we're looking at a final answer for our derivative of 4x to the negative 1/2. Okay. All right, so I'm just going to do one more example real quick. I'm going to just sneak it up here. Well, it's example 3. Okay, what if we just had an x term? All right, what if we just had y equals 9x, and we want the derivative of that? What's the derivative of 9x? Because 9 is a coefficient. Okay, so by definition, that 9 should move into our derivative. So it does. And then what happens with the x? Okay, because we haven't derived an x term yet. Okay, well, we can use the power rule on that. Okay, because what's the unwritten exponent for x? Yeah, it's a 1. So we have technically 9x to the first. We just don't write the 1. But if we have x to the first, that falls under x to the nth power. So it's a power rule situation. So what do? We would move the 1 out front, and then we would subtract 1 from the exponent. So we'll have x now to the 0 power. But what is x to the 0 power, or anything to the 0 power? It's 1, exactly. So we have 9 times 1 times 1, which means we basically just have 9. So the derivative of 9x, I'm going to get rid of that 1 now. The derivative of 9x is just 9. And in fact, anytime we have a term where it's something times x, the derivative will just be the coefficient. All right, so the derivative of 5x will be 5. The derivative of negative 27x will be negative 27. All right, whenever, and then think about it, what's the derivative of just x? Well, the coefficient's 1, isn't it? Isn't x really 1 times x? So the derivative of just an x term will be 1.